we go. The next thing I wanted to show you is how do you do something similar to this, but show your results rather than modify the geometry of your results, right? So maybe rather than scaling each of the panes of this grid, we actually want to just see the attractor points relationship to each of the panes and render it in a particular way. So we can sort of take most of this down, and we're going to begin to tear it apart and modify it. So at the beginning here, I'm going to copy and paste the whole thing down a level. And if you like, if you want to make it a little bit clearer here, group that up. And I want to show you just like another way that I sometimes keep notes is I'll drop a panel in above something like this. And I'll kind of just stretch it across and start taking notes like this. So this was something like that. That was huge, but you get the idea. All right. So just another helpful tip. Back to the text?
Yeah.
I didn't do anything special. I just.
It's fine. It's fine. This cursor's gonna scan geometry.
This is not going to be on the test.
I know, but that's nice to play.
No, there's no test.
Don't do that.
All right. So we're going back here. We're going to start tearing this apart, but let's analyze what we did and start to pick out the packets of information that we want, right? So we probably, if we decide we're going to work with this curve again, we want to keep this curve, divide, and the reference to the curve. We definitely want to keep this information. So I'm going to start chunking it up into groups here. So I've got the curve, reference, divided. I've got the closest points that get remapped into my new domain. This sits off to the right, and that could be any kind of modifier. This is irrelevant. Well, we might need this, but I'm going to leave it up there. So essentially what I'm going to modify here is my input geometry and my output whatever. It could be geometry or it could be some kind of visual display or something like that. So for this exercise, we're actually going to use a surface instead. So that's kind of initially one of the big differences here. So I'm going to go into my top view and go to surface. Go to plane, and you can do a 3-point plane, I guess. And yeah, there you go. Just do a 3-point plane, that should be fine. And right off the bat, I know this right here is not going to be relevant to me.
Including the area part?
Well, maybe that'll stay. If you don't feel like dragging it in again, you probably will use center points again.
Why did you erase that the node that said
The list item at the top?
yeah.
Because I only used that so that I could see at the beginning what size my rectangles were when I was scaling them at first. That was another one of those things that you just use to visually understand. Like if I wanted to see my center points, I could put that on and just click on points and see it. So we're going to subdivide the surface. Do you guys recall how to subdivide a surface that you're referencing in?
Yes, go to... let me find it.
First step is...
Surface and then these
Yeah. And what's the real name of subsurface? Isotrim. Very good. You're learning. So I'm going to reference in this surface. I'm going to go to math, domain, divide domain squared. And we can tell it how many divisions we want. So I'll just say 10. And then we need isotrim under surface, utility, isotrim. So we plug the domain in, we plug the surface in, and there are the subdivisions. Divide, divide domain squared is what you want. Okay, so we've got our surface, we've got a curve referenced, though we might want to make a duplicate so we don't screw the old one up, but we've got a curve referenced. We're going to plug it in and start to do something else. Okay, so I need to introduce what that something else truly is. Let me move that up a little bit. That something else that we're going to do is we're going to colorize each of the cells based on, or rather, we could actually just do the whole surface itself. I guess we'll start with that. But we're going to start to colorize across the entire surface of this grid based on its, attractor point, essentially, right? So its distance to the attractor points. So to do that, I'm going to drop in a couple of points in Rhino. And we're using this, right now we're not using it in an applied manner. We're just using it as an exploratory function, so I'm just going to put a couple of points here in the field. We'll drop one there, drop one there, drop one there. I just put 3 points in Rhino on top of my surface. Okay, so here's the difference. Rather than keeping this, instead of drawing another curve across, now we're looking at, well, what if it's just 3 random points? So I don't need that whole set of data. I can delete it. Down here in the bottom left, I got rid of my subdivide surface, or my divide curve, sorry. And I'm going to params, and I'm going to put in a point reference, and I will set multiple points and just grab all 3 of those points right there. All right. So those points get plugged into the testing, or the points to search on the closest point. And we can get rid of scale. We don't need that either. Do I need this? I think I do. So I'm going to test to the closest points, and I'm going to test their distances from the centroid of my subdivided surface panels, which, yeah, we've got individual surfaces there. So again, right, we're trying to start to compact based on our knowledge of what we have. We don't have to fully deconstruct everything when we're trying to get information, right? So if you look at what we have available to us here, we have a subset of base surfaces. We have 100 of them. So I don't need to deconstruct BREP to get my vertices to test, or to get my faces to test against the centroid. I can actually just plug that directly into my centroid, and that gives me my numerical values to test against. So when I turn that on, you'll see where they are. Yes?
Could you please repeat what you did with the points that you created in Rhino?
Yeah, I'll repeat that. So I just went to this point here, right, a single point,
Yeah.
and I just dropped them into the field. Just, dropped 3 of them on there.
Okay.
Then when I went into Grasshopper, I dropped in a point.
Okay.
I did set one, or sorry, not one, set multiple points, and I just sweep selected all of them. And you hit enter to execute. Yep. You plug that into CP, and what we have here is a remapped set of numbers which are already remapping from 0 to 1. So we borrowed this whole chunk of data, and truly this chunk of information, right, these couple of nodes is what I want you to focus on right now, because they recur often. You'll see these a lot. Or some variation of them. Okay, so we have our centroids we have our points that we're testing against, we have our remap numbers, and then the next thing we want to do is create a colorized representation of their distance. So under mesh, I think it is. And this one might take me a second to remember where this is. Is it mesh colors? No. Display. Hold on, let me check something here. Yeah, all right.
Oh, I think you might have just deleted it. It's not necessary.
Right. Yes, I did. So under gradient, right? Oh, sorry. Under params, under input, we can use gradient, which will give us a visual display. So gradient is a little bit funky. There are a lot of these kind of like graph style nodes that we can use, and they're actually highly customizable in most cases. But you know, gradient for us, we can play around with different color settings. Oh, I didn't want to do that. But if you go to presets, there are a bunch of standard ones that you can modify, or you can double click on it to start to change the colors. When you slide these across, it gets concentrated based on certain properties of those colors. But for me, I want to just use a preset. I'm going to use red, yellow, and blue. So here's how this works. It's going to ask you for the numbers that you're testing for and the numbers that you're testing against. Oh, where was that? There was one other thing too I needed to do. All right. So instead of remapping numbers, so we're slowly whittling away at the definition that we had before. Let me get rid of that too. Instead of remapping the numbers, what I want to do here is obtain my minimum and maximum boundary as two separate numbers. So before, I was constructing a domain, and I told it I want 0, 1 to 1. Now, what I want to do is the opposite. So under domain, instead of construct domain, we want to deconstruct domain. And when we plug that in, or the output that we get is our lowest value and our highest value. And so those get mapped into the gradient. So we'll pull this a little bit closer, and we'll plug the S into L0 and the E into L1. And I would not worry about T, because frankly I don't know what it does because I've never used it. So, all right, yeah. So we're not done yet, right? You notice when you plugged it in, it hasn't done anything yet. And that's because these gradients are going to speak in meshes, not in poly surfaces. Okay, so the mesh will inherently triangulate it and get the gradient of colors across the whole thing. So let's take a look at that real quick. Yes?
Does it have to be 3-point surface, or
No, you could do one.
could I just do like a rectangle?
Oh, yeah, you could do that too. Or planar surface or whatever. I just did a 3-point surface to make it easy. All right, so here's what we need. In order to get our mesh, we need to construct the mesh across the surface, and then we need to assign the colors to that mesh. So when I go up into mesh, I'm looking for mesh UV, which I think is mesh BREP. No. Where's mesh UV? I can find it here for you. Hold on. Mesh surface. Yeah, thank you. Good call. You've used this before, haven't you?
Mesh.
Yeah. So under Mesh Utility, Mesh Surface, hold, yeah. All right. So there's a bunch of different, or there are a bunch of different inputs on this node, and we don't need to use all of them. We obviously need to plug in the original surface geometry. We can and should plug in the same number of UV subdivisions. And then we don't really have to worry about overhang or equalize, because they're just visibility settings by my understanding. So that, I think that changes how it renders the edge conditions. So let's do this. The surface here is your subdivided surface. No, I'm sorry, it's the original surface. Okay, and your U and V are going to be your U count and your V count. Well, I can leave it up there actually, make it clear. And then we have to do mesh colors.
What's the S?
S is the original surface.
Okay.
So with that, we plug in the mesh, right? So the mesh colors is asking for the mesh and the color pattern. So we plug in the mesh, then we plug in the colors, and oh, I got an error.
Oh, no.
Oh, I know why. Because the domain is what has to be plugged into T. Got it. I was thinking of something else there. So the domain of your closest points, or the distance I should say. So you've got the minimum and maximum value, and then you have to plug in the distances as your original parameter, right? So that's taking the place of remap. Yeah,
Wait.
it's pretty cool.
How did we fix it?
Well, we're not quite done here yet.
What's the mesh domain from this guy, CP domain? What is it? T?
Yeah, the distance from CP gets plugged into T.
Okay.
So let's do something here. I need to hide everything except for mesh colors. And we realize here that it's actually not quite what you would expect, right? What we want to see is that we've got some hot spots around these points. So we need to change a few things. And I think that it has to do with the UV value. And let me just double check my notes here, because this one's non-intuitive. Yeah, that's what it is. All right. So this is a new concept for you guys. Well, not a new concept, but it's a new option for inputting data. And it gets used more often than you would expect. It's called an expression, which is very similar to inputting an integer, right? So when you go to params and drop in an integer, and you right click and you go to set integer and you type it in, right? It's like a numerical override. So all of these inputs on your nodes can be overridden with a mathematical equation. So rather than having your mathematical operator come in and actually subtracting by a certain number, you can just pre-program that directly into the input, and that looks like this. So under the U value, you right click and you go to expression, and you can click on expression editor if you want, but I don't typically use that because I only use it for very simple mathematics. So under expression editor, it uses it's similar but not exactly the same as Excel expressions. But it doesn't have any cells to test against. So the number coming in is called X, and then you can modify it to, modify x however you want. So for us, using a very simple expression, we just say x minus 1 and commit changes. So then for v, I think we want to x minus 1 again. There we go. Yeah. So the result is testing of this surface with these hotspots. Yes?
Could you please show us how did you hide the, what's that called? The, you hit something from
Oh, yeah. So when I was hiding it, all these?
those,
Yeah. So to very quickly hide something, you use the middle mouse button,
Oh, okay, yeah.
and that brings up your shortcut menu. I think I very quickly went over it on the first day, but yeah, and then you can turn them all on by doing that, or you can go back in and turn them all off by clicking that. Okay? Questions? Yes?
How do you edit the colors?
You can just modify them in here. If you right click on the white button, you can change what color is being shown for each particular node. If you, I don't know how to delete them actually. Maybe if you just pull it off. No. Ah, pull it up. That'll delete it.
Oh, okay, so it's like illustrate.
And then I think you just drag from the, or double click the white point on the left or something like that, or.
Can you add colors? Is there a...
Yeah, I just did it a second ago. Oh, okay, there it is. You click on that in the top left corner.
Oh, okay.
All right. So I'm going to come around and make sure that you guys are all caught up to this before we move on.